Well, in this video, I will try to cover the basics of vector calculus. So what is vector calculus? For beginning it, we need to talk about vectors. So this is the vector, where this is nothing but the head, which is giving us the direction. This is the magnitude, and this is the tail. And we can connect to vectors through their tails, something like that. Or we can connect to vectors through their heads, something like that. Right? So the important thing is what is actually vector. So this is the vector. Now we should talk about the dot product. You know what is dot product? Let's say this is A dot B, where A and B are the kind of vectors. Maybe they are unit vectors, doesn't matter. So this is the dot product. This is cos theta. Very nice. Now if you haven't the theta, in that case, this is ax bx plus ay by plus az plus az bz. Very nice. It's very easy to identify the dot product. But what is the physical significance? So the first physical significance is we can find out the value of theta through these two equations. The angle between two vectors. Let's say this is A, this is B. This is A vector, this is B vector. We can find out the theta using the dot product, because if we are using the cross product, in that case we have to deal with kind of unit vector. So it's very complicated. So we need to find out the theta, and we have the dot product to find out it. And also we can find out the projection of vector A along any vector. Let's say this is vector B. We can find out the projection of A along the vector B. It's very easy. So this is the second, you can say, physical significance is we can find out the projection of any vector, let's say A vector, along B vector, any other vector. So this is the dot product. Let's talk about cross product. Cross product is looking like something that, right? Sin theta n cap, where n is nothing but the unit vector which is providing us a direction, because cross product is nothing but a kind of vector cross product where we will get a kind of vector quantity. Very nice. Now there's another formula where we need to find out the value through a determinant. This is I, j, k. This is, let's say, ax bx, not bx actually, ay. This is az, this is bx by, and this is bz. A is nothing but the first vector and B is nothing but the second vector. And point to be noted, it is not following the associative rule, or we can reverse it. We can't reverse it actually. In dot product we can, but in cross product we can't. So using the dot product we can find out the projection, or we can find out the angle between two vectors. Using cross product we can find out the perpendicular vector of a plane, or something like that. It depends. You can using the right hand curl or right hand grip rule or screw rule for finding out the direction of the perpendicular vector, but from this you can find out easily the magnitude also. So however, this is about cross product. Now in normal calculus or integral calculus or differential calculus, however, we will deal with a kind of function of scalar function, like fx is, let's say, x square, or fy is y square, or f of x comma y comma z is x plus y plus z. Right? We need to deal with some kind of that functions, but in vector calculus we will do a kind of cross product, dot product, or something like that with these functions, this kind of functions, and also a kind of vector functions. Now the thing is, what is scalar function and what is scalar point function? Both are same. This is a scalar point function because it is depending on the point, which are nothing but a kind of x, y, z variable, where x, y, z are a kind of point in the Cartesian coordinate or polar coordinates. Let's say x is equals to r, y is equals to phi, and z is equals to theta. In that case, this is nothing but the polar coordinate. So very nice. Now the thing is, what is vector point function? Let's say this is f, x, y, and z. I am taking vector point function, so I need to use that symbol, which is nothing but a symbol of vector quantity. So this is equals to, let's say, x I cap plus y j cap plus z k cap. Now this is a very simple function, but still it's a vector point function. Why it is point function? Because x, y and z are points, right? So very nice. This is a vector function, this is a vector function, and this is a scalar function or scalar point function or scalar point function. However, now what is scalar